All right, so 8.1 is called sequence and series. It's going to be your introduction into sequences, which is like a pattern sort of numbers. And then series, and then factorials, and then we'll end it with summation. That's kind of all in this section. So a sequence can either be infinite or finite. Infinite means it's unending, but it's a function whose domain is the set of positive integers. So when we find a series of numbers, we'll be using positive integers. You won't be plugging in negative numbers. The function values that are labeled as such, a sub 1, a sub 2, a sub 3, a sub 4, and so on and so forth, are terms of the sequence. And if the domain of a function consists of the first n positive integers only, meaning that it's going to stop at some point, then the sequence is a finite sequence. There are things called infinite sequences that would be unending, okay? But what we're going to focus on is a finite sequence, so there'll be an end to your pattern. So this simply just says, write the first four terms of the sequence, assume n begins with 1. So you're just plugging in here. So I would start with n being 1. So if n is 1, then I'm plugging in 1. If n is 2, if n is 3, and if n is 4. And everywhere there's an n, I plug in that value. So this would be 2 times 1 minus 4, 2 minus 4, which is negative 2. This would be 2 times 2 minus 4, 4 minus 4, which is 0. 2 times 3 minus 4, 6 minus 4, which is 2. 2 times 4 minus 4, 8 minus 4, which is 4. So some of them are a pattern, a linear pattern like this is, okay, but not all of them are. We're going to learn about arithmetic, sequences, and geometric in the next two sections. For right now, we're just saying it could be any kind of sequence. So when you list the terms, you'll literally do that. Like on the quiz or the test, you'll get like a line in which you are listing your answers. So it starts with the first one, which is negative 2, then 0, then 2, then 4. So it doesn't go in order from smallest to largest value. This one does, but it doesn't always. It just goes in order from what you plugged in. So starting with 1 and going up to where it says. So in this case, it was the first four terms.
Do you do 0 or do you just start at 1?
It'll say assume n begins with, and it's usually 1.
Okay.
Yep, if it doesn't, it'll tell you otherwise. Like when we get to summation, you can see where it changes. All right, you do B. So again, first four terms.
And it's supposed to start at n too.
Well, it'll say first four terms, first 5 terms, first 3 terms, something like that. Yeah. God bless you. So once you plug them in, you should have gotten 1 4/3, 3 halves, and 8 fifths. Easy stuff, right? Just plug them in. And yes, you can get questions just like this. Obviously, they'll get jazzier when you start plugging them in, but there are some where all you're doing is plugging them in. Question so far? All right, and then obviously, like I just said, maybe they up it a notch. Maybe you've got an exponent and fraction. No matter how many times you see n appear, if n was in that function 7 times, you plug that same n in for all 7. So this time the directions say first 5 terms. So just pay attention to the directions. So I would do n as though as it's 1. So you should have gotten negative 1/2, 2/3, negative 3/4, 4/5, negative 5/6. So one of the reasons why I pulled this example is so that you can start to identify like what's happening, because you're going to eventually work these backwards, where you get given the answers or you find the answers, and then you have to work your way backwards to figure out what the initial statement should have been, what the initial function should have been. So notice by changing like the exponent on a -1, this changes my signs from positive to negative back and forth like that. Sometimes I can start with a whole number and split it into a fraction, which is what happened here. And I would do that by putting something in the numerator and the denominator. And if they're ever changing like these are, then the n has to be involved with both. So you have to start thinking about what kind of changes would result in what you're looking for. Everybody good on that one? Raise your hand if you got it right. Okay, good. All right, then there's ones where you're jumping to a specific term. So the fact that I had n to the first, n to the second, n to the third, n to the fourth, there may have been a connection between them from 1 to 2, 2 to 3, but there doesn't have to be. And you'll see in a minute when that exists. So for right now, we're saying, okay, if I gave you this function, I could ask for any term in that function. I can ask for a sub 10, a sub 25, and I don't need any other information but the initial function. So if it says a sub 4, then I'm saying, okay, plug a 4 in everywhere there's an n. So this would be 4 squared over 2 times 4 plus 1, 16 over 8 plus 1, which is 9. And no matter how many times people reduce that to 4/3, that's wrong. Okay, I've seen it done 8 million times. Like you look at it, you're like, oh, it's perfect square. That doesn't reduce. That's 16 over 9. Yep. So this indicates what I'm plugging in for n. So I could have said literally n a to the 100th. And you know you have to plug in 100 there. Questions so far? All right, these, in my opinion, is the hardest to teach because I can't tell you this is step 1, step 2, step 3. This is kind of like a proof or a puzzle. You have to like figure out what's happening, okay? I can give you strategies to approach, but other than that, each one can result in something totally different. So these you are given as though this is the set of the first 5 terms in a series. You have to figure out what got you there. So I would say that the most common mistake people make is going, okay, from 0 to 3, 3 to 8, 8 to 15, 15 to 24, what happens there? It's not always going to be adding the same thing or multiplying by the same thing. What's a better way to approach it is say, if my first term, so if n is 1, then my result is 0. If n is 2, then my result is 3. If n is 3, then my result is 8. If n is 4, then my result is 15. And if n is 5, then my result is 24. So the connection happens from left to right here. I'm doing the same thing down that ladder, like down each step I'm doing the same act, but it doesn't mean I have to do, it's not like adding 2 every time or adding 3 every time. You have to figure out the pattern from left to right. So from 1 to 0 is a hard thing to figure out. You're either subtracting 1 or multiplying by 0, right? None of which you can do to the rest of them. It's not the same thing. But as you look at what happens on the right-hand side, there's a significant jump between these numbers, yes? Usually when it's something like that, I'm not adding, that's not going to be consistent, I'm not adding something. Usually it's like either a multiplication or even an exponential growth. So as you look at that set, is there anything that jumps out to you that you think might be happening? Alex?
N squared minus 1.
Let's try it. So if we think it's n squared minus 1, that should work all the way up and down. So this would be 1 squared minus 1. That works. This would be 2 squared minus 1. That works. This would be 3 squared minus 1. That works. 4 squared minus 1. That works. And 5 squared minus 1. That works. Good job, Alex. I'm always curious to see who that one person is that can figure it out first. You didn't get it until you saw the arrows. Because your brain immediately goes, what's the pattern going from left to right, which is what's wrong, right? It's not you're finding a pattern. It's not that. You're finding what's happening to those numbers on the left to get to the right. All right. Now look at B. So if n is 1, it's 2/3. On the last slide or on the left side? A sub n equals n squared minus 1. Mm-hmm.
Well, no, because it starts with 1, not 1.
So if you did n over n plus 1, right, then it would be 1 over 2 for the first one. So n over n plus 1 doesn't work, but you're on the right track. As soon as you see it go from a whole number, which you know it's going to be, you're plugging in whole numbers, right? We're plugging in integers, and integers are whole numbers. Then I know I have to split it into a fraction. That means there's going to be a fraction in what I'm doing. That's first of all. If it's not the same number in the numerator every time, then I know, or the same number in the denominator every time, then I know I have an n in the top and in the bottom. I'm changing both parts. Does that make sense? So now the question is, how am I going from 1 to 2 and 1 to 3? Let's try it. N plus 1 over n plus 2. So this would be 2 over 3. That works. 1, 2, that works. 1 plus 2, that works. 1 plus 2, that works. And 1 plus 2, that works. So there is the pattern. Sometimes there's more than one way to do it. There certainly is. It's just one teeny tiny part of the big picture. It's a bad plan. Oh, we didn't talk about this in this class. Stop putting that nonsense out there. Maybe it will be the easiest question on the whole test. What? All right, so recursive sequences look more complicated than they are. Recursive sequences actually have a pattern. So you are using the term before it to get to the one after it. Okay? This one would have a pattern working if you went from the first one in the list and to the right. Sometimes it's a linear pattern, sometimes it's not. But you need the one before it to get to the one where it's at. So what confuses everybody is the k plus 1 and the k. Okay? All this means is that in order to get to the next term in the sequence, I have to use the term before it to plug it in. So this is to define a sequence recursively. You need to be given one or more of the first few terms. So this is not a situation in which I can say, give me a sub 10 without giving you something before it. You have to get at least one of those terms before it. So if I did give you a sub 1 and I wanted to find the next one, then I'd be looking for a sub 2. This 2 is the k plus 1, which means 1 less than k plus 1 would be a sub 1 plus 10. So I'm basically using the one before it to plug it in. So the next one in the line would be a sub 3. And to do that, I would do the one before a sub 3, which is a sub 2 plus 10. And then a sub 4, and so on and so forth. This would be a sub 3 plus 10. So the difference is you're using the one before it. So if a sub 1 is 5, then this is 5 plus 10, which is 15. If a sub 2 is 15, then this is 15 plus 10, which is 25. Exactly. And so on and so forth. So this time, this is actually what we're going to get to is called an arithmetic sequence in which you're adding the same thing every time. They're not always like that. You could have a 2 times something plus 10 in which it won't be the same every time. But this one does. So recursive, don't let the k plus 1 scare you. That just means that to find the next one, you have to use the one before it.
What is the one before it?
Whatever number comes before it. So if I'm looking for a sub 2, then on the right-hand side, a sub k is a sub 1. Does that make sense? No. If this is 2, if I'm looking for 2, if k plus 1 equals 2, think if k plus 1 equals 2, then k would be what?
1.
1. Solve it.
The number before that.
Which this would be 1. If I'm looking for the 5th term in the sequence, if I'm looking for a sub 5, then I would have to plug in a sub 4.
Okay.
Does that make sense? Okay. We're going to do another one. I think it's hard to look at the first time because it's so confusing with that k plus 1. But it just means use the one before it to get to the one you're on.
14?
No, not the value plus 1. All right, so this says first 5 terms in the sequence. What's the first term in the sequence?
15.
15. So a sub 1 is 15. To get to a sub 2, I'm going to take the one before it.
14. 15.
No, I plug it into here.
Look,
So I take the one before it, which is 15 plus 3.
You're making no sense.
Okay, let me explain it in the calculator. So, okay, a sub 1 is 15. So you have to find a sub 2. So to find a sub 2, you got to look at the one before a sub 2, which is a sub 1. So if a sub 1 is 15, you're going to do 15 plus 3, which is 18, and that's ace of 2.
He's not angry, he's just being loud.
So for the next one, which is ace of 3, you're going to find that by getting ace of 2 plus 3, and we know that ace of 2 is 18, so plus 3 is 21.
Do it again, right?
Okay, so ace of 4, you have to get the one before it, which is ace of 3, which we just found to be 21. So 21 plus 3 is 24, and that's ace of 4.
How many are we finding?
We're going to find 5, so we got to find ace of 5. So you have to get ace of 4, which we just found to be 24, plus 3, 27, yes.
There you go.
He got it. He's learning so fast.
15 is the first term. It says the first 5 terms. So most common mistake here is to skip 15 and then add on 30. That's wrong.
What did you say not to circle?
Don't just like go, here's my answers. Here, 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 here. I'm going to give you a line, and then you're going to put all your answers in the order in which you get them on that line, including the first one if it's recursive, because it's going to say the first 5 or the first 4, whatever it is. Exactly. You're so smart. All right, so this one says, write the first 5 terms of the sequence defined recursively. So the same thing we did first. And then we're going to use the pattern to write the nth term of the sequence as a function of n. So you do the first part, figure out the first 5 terms of a recursive sequence. Notice the k plus 1, that's how you know it's recursive.
Fraction.
Mm-hmm. Do we get it right? The first part? Yeah. So again, don't be careful. Don't put that in order from smallest to greatest, right? We want it in the order in which we received, which was 81, 27, 9, 3, and 1. That's the first part of this. Now the second part says use the pattern to write the nth term of the sequence as a function of n. That means give me the equation that gets you this without it being recursive. So go back to what we did before. If a is 1, or if n is 1, then I have 81. If n is 2, then I get 27. If n is 3, then I get 9. If n is 4, then I get 3. And if n is 5, then I get 1. So we know it's something with 3, right? Because we used a 1/3 to get to that point, right? We can raise it to the powers, right? So how could I get 3 to the 81st power?
You can do a negative exponent.
I could do a negative exponent.
Oh, so
Mm-hmm. So if 3 is my base, let's say that. If 3 is your base, and I have to involve 1 somewhere there, right? What gets you to 81 from 3? I mean the exponent, sorry. Like 3 to what power is 81? 3 to the 4. So how do I get 3 to the 4th involving my 1?
Times 1 over n? Or under n?
Well, look at it this way. This 27 would be 3 to the 3rd, right? How do I involve 2, or how do I get the 2 in my exponent to be a result of 3?
Over 2. N plus 1.
Okay, so let's try n plus 1. So if I had 3 to the n plus 1, then this one would be 3 to the 2nd. So that doesn't work, right? 10 minus n. So 10 minus 1 would be 3 to the 9th. Too big, but you're on the right track. 5. So if I did 5 minus 1, I'd get 3 to the 4th. Right, that works. How about 3, and then the next one would be 3 to the 2nd, or sorry, 3 to the 5 minus 2. That would be 3 to the 3rd. That works. And then go to the next one, 3 to the 5 minus 3. That's 3 to the second. That works. And 3 to the 5 minus 4. And 3 to the 5 minus 5.
You're so smart.
So this would be a sub n equals 3 to the, we said it would be 5 minus n. Now this is, I'll tell you right now, there's already, I think another class came up with another way to do it, which is the 1/3 and the n minus 5. So there can be more than one way to do this, okay? It doesn't mean that's the only way, but you want to check to make sure it works for all the parts. So this is a series that can be the result of a recursive series and also the result of a normal regular series, okay? Same answers. All right, I think on your notes, if you downloaded them today, you should be here, right? Yeah, I fixed them. Okay, so factorial, this is the exclamation marks. Okay, factorials are not scary. They're actually super easy. All an exclamation point means is that that number is itself times all the numbers resulting till you get to 1. So if I have 5 exclamation point, which is read as 5 factorial, that is the same thing as saying 5 times 4 times 3 times 2 times 1. Okay? Super easy.
When she knows what
One of the
classes
maps.
she's taking.
You actually might be totally right. I think I did teach this to geometry honors. Yep, I think you're right. So the other thing is the special case, the 0 factorial is 1. Okay, so if you ever see that, that's not something you can do. You can't work backwards from 0. 0 factorial is 1. It's kind of like if you raise a power to 0, it's 1. There's no way to get that other than knowing that. Okay, so 0 factorial is 1. So you're going to see it in your series like this. So first 5 terms of the sequence. So a sub 1 would now be 1 over 1 plus 1 factorial. A sub 2. 1 over 2 plus 1 factorial. A sub 3, 3 plus 1 factorial. A sub 4, and a sub 5. So this becomes 1 over 2 factorial, which is 1 over 2 times 1, or 1/2. This is 1 over 3 factorial. 1 over 3 times 2 times 1. We already know 2 times 1 is 2 times 3. You only have to do that last step, 1/6. 1 over 4 factorial, which is 1 over 4 times 3 times 2 times 1. We already know 1 times 2 times 3 is 6, so I just have to multiply times the 4.
Yeah, how do you know what the factorial is?
What do you mean?
So you change factorial into 1?
Factorial is that number multiplied by every number from itself down to 1.
Were you paying attention?
No. Okay, good.
I think that's so much pizzazz to the math problem. Like it's like 1 over 4. Why?
So 1 times 2 times 3 times 4 is 24 times 5, 120. And then 1 over 6 factorial. 6, 5, 4, 3, 2, 1. So 120 times 6, 720. And again, it's a series, so we're going to list them in order. 1/2, 1/6, 1/24, 1/120th, and 1/720th. Super easy, right? So factorial. 5 factorial. 7!
See, that's so much
With
more
pizzazz, yeah. So I'm going to show you a trick here. So instead of writing this out as 5 times 4 times 3 times 2 times 1 over 7 times 6 times 5 times 4 times 3 times 2 times 1, because what's going to happen? I can cancel out the 1s, the 2s, the 3s, the 4s, the 5s, right? So a shortcut to this is pick the larger of the two, whether it be in the numerator or the denominator, and break it down until you hit the smaller of the two. So I'm going to leave the 5 by itself, and in the bottom I'm going to take 7 and say 7 times 6 times 5 factorial, because that would finish it off. Cancel these out, and I get 1 over 42. Now think about it in terms of an expression. What's bigger, n plus 2 or n? n plus 2. So if I wanted to break n plus 2 down, the first thing would be n plus 2. What would be the next one? N plus 1. What would be the next one? N. And I have n factorial over n factorial. Those cancel. And I would do n plus 2 times n plus 1 and then FOIL it out. Easy stuff, right? Okay, last thing, which is summation notation. So that little sigma, this is such good college prep because that little sigma is like a little fancy E, is in every fraternity and sorority name on the planet. Okay, so yeah, so that is called sigma. Okay, it is this actual summation sign. And in regular summation, so we're going to learn two different kinds of summation, like infinite and finite. In a finite summation, which is what this is, the I is basically just your variable. So the bottom, that I can change. It can be X, it could be N. I mean, it could be X, it could be Y, it could be M, it could be any kind of variable usually. But that just tells you what's the first term you're plugging in, okay? Or the lower limit. The number at the top, which in this case where that N is where you're stopping. That's the upper limit. And then whatever's to the right is the expression in which you're plugging those numbers into. So what's here will be an actual expression, or even if it was just like X, then you wouldn't have to do anything with it. You would just be plugging those numbers into X, so it would be itself. But at the end, you're going to have a series of numbers, and instead of being a series, you are adding them all together. It's a summation. So you're adding them all together to get one single number. So it would look something like this, and it just says find the sum. Okay, so the bottom again is where I start, which means this time what's the first number I'm plugging in? 0. And then the top is where I stop. So I go from 0 to 1 to 2 to 3. So the 3 is not how many you're plugging in, it's where you stop. So I plug the 0 in here. So I get 0 plus 1 times 0 minus 2. I get 1 times negative 2, which is negative 2. And then I plug in 1. 1 plus 1, 1 minus 2, 2 times negative 1, negative 2. And then I plug in 2. 2 plus 1, 2 minus 2, which is 3 times 0, or 3. Nope, or 0. And 3. 3 plus 1, 3 minus 2, 4 times 1, which is 4. So if that was a series, I'd write them out as a series, but it's not. It's a summation, which means take all these numbers and add them together. So negative 2 plus negative 2, which is negative 4, plus 0 plus 4 is 0. So most common mistake is the number at the top being how many terms there are in a summation. That's where it's wrong, okay? Number at the top is where you stop. Number at the bottom is where you start. Number at the top is where you stop. So if you have a graphing calculator, and it's a newer one, so the TI-84 Plus, I'm going to show you how to use that one first because the other one's a nightmare, but I'll show you how to use it too, okay? How about a new one? Okay, so this, again, the new one. If I go to my math menu, and I scroll all the way down to 0, or you hit 0, you should see summation. So it looks just like that. Gives me the little spots to fill it in. So the A that's flashing is the variable. It doesn't matter what variable you use, so we're going to use X because that's the variable that's on this button. I'm going to use X. The spot next to it is where I start at, which in this case is 0. If I arrow over, it brings me up to the top. We stop at 3. I arrow over, and then I have to enter in my expression. Now I've got to group together the X plus 1 and the X minus 2 because I want it to, oops, that's not an X, because I want it to multiply it. I want it to multiply the expressions first before it does the, ooh, that's new, okay. Anyways, I hit enter, yep. There. I got 0, which is our answer, right? So you can check any summation ones using this, okay? Just be careful. The mistakes I saw first hour was not putting the parentheses on the end, so or not putting the parentheses on the X plus 1, so it grouped it funny. And also using a negative 2 instead of a -2, and then it treats it like it's multiplication, and it gave you the wrong answer. So it will let you do it, and it won't yell at you. So be careful. Okay. So now if you have the old one, so who's got an old one? I can borrow. I'm gonna put this picture. This is kind of like the directions on how to do it. I'll put it right on the assignment, but just so you know how to do it. Okay. So this time you have to do 2 different menus. You have to say sum and sequence. So you're basically creating a sequence, which you could do all of your sequences by doing what we'd do if we just do the sequence part, but we want them to add it together, so you got to use both. And they're both under the second stat menu, which is the list menu. So if I hit second stat, I get to the list menu, and I go over to where it says math first, and I go down to where it says sum. And then I go back to that same stat menu, but instead of going to math, I go to OPS, and I go down to where it says sequence. So it's saying, take the sum of the sequence I'm about to feed you. And then here is the complicated way to type it in. So you got to separate it out because it doesn't give you the little sigma notation. So I have to first put the x, what is it, x minus, I've done this problem 17 times, I can't remember. X plus 1, x minus 2. And you want to group that together. Oh, I need another set of parentheses. So I want it to do that first. So I have to insert parentheses here, parentheses there. And then you have to put a comma. The comma's here. We haven't really used it. The comma's there. And you have to put what variable are you using as your variable, which is x. So I'm going to click on x. And then I have to put a comma again. And I have to say what's my lower bound. So what am I starting at? I start at 0 this time. And then the comma again. What's my upper bound? And that's the number at the top, which is 3 this time. And then a comma again. And how many you want to go by each time, which is 1. And then close your parentheses. And then hit enter. And you get your answer. So it's a lot more work, but it gets you the same answer, okay? So sequence, sum, then sequence, then your original expression, comma your variable, comma your lower limit, comma your upper limit, comma 1.